Morning everyone. Am I audible to you guys? Am I audible? Okay. Okay, so last class we have mainly discussed about hashing and how hashing function can be used for message authentication. Okay, so your hashing function mainly provides authentication but not the confidentiality. So today we will just see a little bit of more theoretical knowledge about hash functions in cryptography. So there are three main properties of hash functions. Okay, one is your pre-image resistance. Pre-image resistance means it should be computationally hard to reverse a hash function. In other words, you can say if a hash function h produces a hash value, suppose h is your hash function and it produces a hash value z or z, then it should be difficult process to find any input value x that hashes to z. So this property mainly protects against the attacker who only has a hash value and is trying to find the input. Okay, then the second property is the second pre-image resistance. So this property mainly for like if input and its hash function is known to the third party, still it should be hard to find the different input with the same hash. Okay, so other words you can say like if a hash function h was input x, that will produce a hash value h of x, then it should be difficult to find any other input value y such that h of y equal to h of x. Okay, it should not be like that. Okay, so first property is pre-image resistance. It should be computationally hard to reverse the hash function, and second is the second pre-image resistance means if um, suppose the input and hash function is given, then it should be hard to find different input with the same hash function. So this property of hash function mainly protects against an attacker who has an input value and its hash and wants to substitute different value as legitimate value in place of original input value. Okay. Next is your collision resistance. Okay, collision resistance is your third property. So this property means it should be hard to find two different inputs of any length that results in the same hash. Okay, so this property is also known as your collision free hash function. But as we have discussed in the last class, actually there cannot be a hashing technique is never be collision free. So all we need to make sure that number of collision is less. Okay, so here you can see if a hash function is h, it should be hard to find any two different inputs of x such that like again it's same hx and hy should not be same. It should not produce any collision. That means for any two input, the value of hash value should not be same. Okay. Since like hash function is compressing function with fixed length hash values, so it should be impossible for a hash function to have collisions, and this property of collision free only confirms that this collision should be hard to find. Okay, and if a hash function is collision resistant, then it is also a second pre-image resistant. Okay, so this property mainly makes it difficult for an attacker to find any two input values with the same hash. Okay, so these three are the main properties of any hash functions which is used in cryptography. One is the pre-image, the second is the second pre-image, and third is the collision resistance. I hope collision resistant it's already clear to you guys. Last class I have explained how we get a collision and what are the techniques for collisions and all. So next is designing a hash function or hashing a algorithm. Excuse me. So your hashing function is nothing but a mathematical function that operates on two fixed size block of data to create a hash code. Okay, and this hash function forms the part of the hashing algorithm. Okay, so hashing algorithm mainly involves rounds of different hash functions just like your block cipher. Okay, suppose this is the process. So suppose the size of each data block varies depending on different algorithm, because there are different algorithms are available for hashing. So depending on that algorithm, the its size of the block will be um, processed. Okay, so typically the block size of any hash function is from like 128 bit to 512. So this is just generic block diagram of any hash functions. Okay, so your hashing algorithms will mainly involve different terms. Okay, so hash function is this one, and this hash function is applied in here. So for example, in the first block you will apply a hash function, there will be a output, then that output will be given to the other block of hash function, then again the output of that hash function will again given to the next hash function. So it's like a chaining process, or you can say different rounds are involved, just like your block cipher. Remember in AES and DES, data encryption algorithms also, there are rounds of blocks, and in every block we process some block of input message. So this is similar kind. So each round takes an input of a fixed size, and typically it's just a combination of like most recent message block and the output of the last round. Okay, and this process is repeated for as many rounds as are required to hash the entire message. Okay, so this is like generate diagram. Now since hash value of first message block becomes an input of the second hash operations, the output of which alters the result of the third operation and so on. Okay, because here you are giving a hash function, the output is given to the second block, then again the output is given to the third block. Okay, so every time you are changing the operations. Okay, so this effect is known as your avalanche effect. Avalanche effect I have mentioned during block cipher also. So avalanche effect results in substantially like different hash values of two messages that differ by even a single bit of data. That means even if you make a single change in one block of hash function, the output will be again sent to the next block, right? So even if you change a single bit in one hash model, the entire message will be changed. Okay, so therefore you should just understand the difference between hash function and the hash algorithms. So hash function generates a hash code by operating on two blocks of fixed length binary data. And hashing algorithm is a process of using the hash function, like especially how messages will be broken up and how the results from previous message block are chained together. Okay, so hash function will just create a hash value, or you can say digest, then hash, and using the hash algorithm you are going to use the hash function to break your message block and generate a value. Okay. Okay, now there are some popular hash functions. The most popular one is your MD. MD means your message digest. MD5 is the most popular and widely used hash function. Okay, so in message digest we have MD2, MD4, MD5, and MD6. Okay, so this MD5 is mainly used for your internet standard RFC 1321, and it is 128-bit hash function. Okay, MD5 digest have been widely used in software world to provide assurance about integrity of transferred files. For example, like in file servers, whenever it's normally provide a pre-computed MD5 checksum for the files so that the users can compare the checksum of the downloaded file to it. So from very beginning, means after these functions are proposed by the scientists, these are mainly used for file transfer. Okay, again, like in some period later, some people just found out that there is a collision problem in MD5. Okay, so an analytical attack was reported to be successfully only in 1 hour of using computer cluster. Okay, so this collision attack resulted in compromised MD5, and therefore it's no longer recommended to use. However, it's still the popular. Okay, second type is the secure hash function, or SHA. Okay, so this SHA mainly have four types of algorithm: SHA0, SHA1, 2, and 3. But even though they are from the same family, they are structurally different. Your SHA0 or SHAO is 160-bit hash function and is published by your NIST, National Institute of Standard and Technology. This one is given by NIST. Okay. But SHO has few weakness and it did not become very popular. So later SH1 was designed to correct the weakness of SH0. Okay, so SH1 A1 is most widely used for existing SHA hash functions. So and it's mainly employed in secure socket layers. Okay, for security purpose. Then again, SHA had some problem was there because some collisions were discovered there, because the main property of hash function is it should be collision free or collision resistant. So even if your hash function cannot get rid of collisions completely, but it should be as minimized as possible. So once they found out that there is some collision problem, they just developed the third one, which is SHA2. So again, SHA2 family has four other variants: 224, 256, and 384, and 512. And depending up on the number of bits in the hash values, these names are given. However, there is no attacks have been reported for SHA2 till now. Okay, then SHA Phi is also known as KICAC algorithm. And this one is again developed by NIST. This is just a bit stronger than your SHA tool. Next type is your race integrity primitive evaluation message digest. Okay. Okay. So YPMD is your race integrity primitives evaluation message digest. This is a set of hash functions mainly designed by open resource community and generally known as a family of European hash functions. So again, this type again has some different versions like MD, then normal one, the original one, then 128, 160, and there's also 256 and 320-bit versions of algorithm. So your original MD is of 128 bit and based upon the design principles used in MD4, and later of course they had some security problems, therefore they just developed a modified version which is YPMD 128 bit. Khalid on this? Yes. Wait, no, wait, no. Wait, yeah, Monday. Mute us. Nine, mute for nine. So yeah, so RIPE MD 128 version is just a quick fix of all the problems had in original RIPE MD. Then again, RIPE MD 160 is improved version of the most widely used version in the like 256 and 320 bits. Versions are reduced like accidental collisions. But yeah, again they have some collisions problem. Okay. However, the 256 and 320 bit versions are relatively secure than Rapid MD, RIPE MD 128 and 160 bit. Okay, the third type, fourth type is Whirlpool. The Whirlpool is 512 bit hash function. Nano Moit So this Whirlpool function is derived from the modified version of advanced encryption standard. Okay, and if you remember, this AES encryption function was mainly designed by Vincent Wiseman. Okay, bye bye. So there are again three versions of Whirlpool: Whirlpool O, Whirlpool T, and just Whirlpool. Okay. So next is the application of hash functions. So there are two main functions for application of hash function. One is password storage. So instead of like storing the password in clear, mostly like all logon process store the hash values of passage or password in the file. Okay, so the password file consists of tables of pairs which are in the form of like user ID, HP. Okay, so the process of logon is like you can depict with the help of like there will be a password and there will be again a ID. Then there will be a device. In this process you can just say like uh, suppose there will be a user identity B, then there will be a password for the user. Okay, then there will be a device, then a table will be there, and in the table in the device, okay, in device there will be a table, and in that table will have both ID and the hash function of that password. Okay, so once user send it, what it will do, it will generate a hash value. Okay, then the device or the second person will also generate a hp function. Okay, then they will check if they are equal or not. Okay, if they are equal, then means it will send a decision. This is mainly like if you want to access any device. Okay, so if both hash are equal, then device will say that okay, you can access the device now. Okay, suppose like intruder can only see the hashes of password. Even if he like access the password, he can neither log on using hash nor can he derive the password from the hash value, since hash function possesses the property of pre-image registers. Okay. So second is the data integrity check. So it's the most common application of all the hash functions. Okay, and it is used to generate a checksum on data files. And this application provides assurance to the user about the correctness of the data. Okay, so the integrity check mainly helps the user to detect any changes made to the original file. However, it does not provide any assurance about the originality. Okay, so attacker instead of modifying the file data can change the entire file and compute altogether new hash and send it to the receiver. And this integrity check like application is mainly useful only if the user is sure about the originality of the file. Okay, so integrity, in case of integrity, we will just make sure that no modification has been done, but if the entire file is the wrong one, that it cannot help it. Okay, so this is all about hashing. Then in uh, let's start in the next class, I guess. I'll explain the md5. Okay, there are different hash algorithm you can see, and out of all we are just going to check md5, then again we will check sha. Okay, so in next class I'll explain the md5 algorithm. Okay, I have to go now, so I'm just stopping it here. Okay, so that's all for today. So in next class I'll explain md5, that is tomorrow. Okay. Okay, thank you. I'm ending the meeting now.